Today, I am John Patrick Pirodi, together with my thesis partner, Rick Jenser Y. Chua, and our thesis advisor, Dr. Joseph Albert M. Mendoza. Today, we will be presenting our study titled Improving the Photocatalytic Degradation of Pyerene using tungsten trioxide titanium dioxide nanoparticles. Pyerene is one of the known polycyclic aromatic hydrocarbons or known as PAH that causes pollution in water. This study focuses on the degradation of pyrogen using UV light to gather data in batch test and column test. The nanoparticle used was tungsten trioxide titanium dioxide, and it was experimented into different columns such as titanium dioxide in powder and coated zeolite, as well as the mentioned nanoparticle. Neural network is a system that can learn the interconnected nodes or neurons in a layered structure that resembles the human brain. The photocatalytic degradation data of pyrene was input in Artificial Neural Network or ANN model aided by MATLAB. And because of that, accurately predicting using artificial intelligence is advantageous for the experimental outcomes. ANN model can be useful for the future chemical engineering experiments.
And for the introduction, the polycyclic aromatic hydrocarbons are toxic environmental pollutants and are commonly found as contaminants in bodies of water. It is divided into two parts, which are the low molecular weight and high molecular weight, and it varies due to the fewer fused benzene rings and the latter having four or more. Uh, Titanium dioxide photocatalyzed degradation has been used in degrading and removal of various organic compounds since the process can achieve effective removal with mild pressure and temperature conditions. This study will be limited to the usage of the said nanoparticle as photocatalyst exclusively, and no other types of alternative nanoparticle photocatalyst will be utilized in the study. And the objective of the study is to explore other methods in improving the photocatalytic degradation of pyrene using tungsten trioxide, titanium dioxide nanoparticles.
And now for the results and discussion. The neural net fitting network uses a nonlinear input-output network with a layer size of 10. The parameters used are the concentration treated with respect to concentration over initial concentration, or the fraction of pyrogen degraded in all columns. The figure shows a performance plot of all the time series generated for a closed loop in neural networks. There are only 20 data values for batch test, which is a limitation for the neural network time series, as the number of observations for the training of the neural network model. Even though the number of the data is limited, the ANN model developed was satisfactory for both training. R is equal to 1 and testing is equal to R 0.9960.
And in this part, it can be seen in the figure that the reaction of photocatalytic degradation of aqueous pyrene in different columns. It shows that the concentration of pyrene increases as the volume increases, which means that the pyrene was absorbed from the source light. By adding water into an aqueous solution, it can decrease the concentration of the solution. Pyrene has low solubility in water that might cause the precipitation of pyrene that gives the increase in concentration. For the 18 days period, there's a 10 ppm pyrene concentration, and for 20 days period, there's 0.1 ppm pyrene concentration. Next. And the most efficient among the photocatalysts is the titanium dioxide coated zeolite with 88.76% removal. The light source done was a UVA lamps. The difference with other method that causes a low percentage of removal is that the longer column operation and has a shorter time that the pyrene spends in the column. Regardless of the volume treated, there's an improvement in degradation of the pyrene as shown in the figure. This result can be resulted through the aid in addition of mirrors under the column test operation. From knowing the different removal percentage of the photocatalyst from different column, it shows that the more organic the process, it is more efficient than the inorganic method.
Next is the results for the ANN for batch C. The neural net fitting network used is a nonlinear input-output network. From the graph, the blue line indicates the target data, which is the original data that undergoes the training, and the red line is the testing or prediction line that was obtained in different periods. The best validated performance can be seen in the first figure, which have the value of 0.10287 at 88 epochs. In comparison with the graph from the classical method, which is done in the batch test, it shows the randomness of data in time series that can be seen in the figure, that the values between original and predicted data are close and the error between the values are minimal. There are only 20 data values per batch test, which is a limitation for the neural network, as the number of observations for the training of the neural network model. Even though the number of data is limited, the ANN model developed was satisfactory for both training with a R value of 1 and testing with R value of 0.9960. The modeling of adsorption equilibrium data using the theoretical expressions like the Langmuir and Freundlich isotope, which is used in this experiment, was further examined using the neural network basic model and the architectural model. MATLAB's ANN app can determine the output of the experiment. Using this method, the researcher found that the larger data used for training can give a greater accuracy for the network. The higher number of neurons, the better it predicts the data. There's a lot of data for the absorption of the Pyerene in this study. ANN model is more than enough to predict the experimental outcomes as seen with the regression plot earlier in the figure. The data fits but still needed greater amount of data. ANN is an easier method that can be used for the improvement on the adsorption equilibrium of Pyerene and replace the theoretical adsorption isotopes, which are the Langmuir and Freundlich isotopes.
And for the ANN column test, the 20-day period test result will be used for the neural network fitting. Next. The parameters will be used were all volume treated with respect to concentration in all columns. As shown in the first figure, the performance plot of the time series generated of a closed loop in neural networks. From the graph, the blue line indicates the time series, which is the target, and the original data that undergo the training. And the red line is the testing or the prediction that was obtained in different period. The best validated performance can be seen in table 2, which have the value of 135.065 at 8 epochs. In comparison with the graph from the classical method, which is done in the column test, it shows the randomness of data in time series that can be seen in figure in the next figure, that the errors increases between original and predicted data, but from there it can help to predict the data experiment in removal of pyrene in specific volume treated and concentration. And as you can see in the next slide is the table I mentioned with the observation of the training and the validation and the test of the ANN time series data of column test. Okay, next.
And The improving of photocatalytic degradation of pyrene using nanoparticle was shown in this study using batch test and column test. From the batch test, it is found that the removal of pyrene is faster in titanium dioxide coated zeolite than titanium dioxide powders only. This might be because of the zeolite's high affinity for water molecules and the increased production of OH radicals during photocatalysis, where the water that the zeolite has absorbed reacts with the whole oxidation on the photocatalyst surface. For the neural network fitting for the batch test data, the training yielded a value of 0.10 MSE and the R value of 1, which indicates a perfect fit for the trained neural network with the provided batch test data. And for the column test,
For the column test, it shows the UV light can degrade the pyrene in a certain time as shown in the data. The columns used in the column test shows that the most efficient among the photocatalysts is the titanium dioxide coated zeolite with 88.76% removal. The additional of the mirrors also aided the process to degrade the PAH quickly and efficient. The application of ANN time series for the column test gives more data that there's a decrease of MSE in the data as the epoch increases. From that, it can be seen the set of errors that needed to be measured for the future experiments. The additional data set of for the column test can help the ANN time series to have an accurate data and lesser errors. ANN is recommended for a mass photocatalytic degradation of pyrene using nanoparticle since it scopes set a large set of data and predicts the future outcomes. And thank you, that's all.